Have you ever played Tetris, but using the alphabet? Introducing Alphabetris, or Alphabet Tetris. Tetris is a popular classic game where blocks fall down a column and you have to move them left or right to make rows disappear. The alphabet is a series of letters. Putting them together produces Alphabetris, where the point is to move letters left and right as they fall to create words, and each time a valid word is made, you get points, and the word disappears. Question is, how do you make such a wonder? The answer is actually pretty easily. We just open VS Code and start writing some 350 or so lines of code. First, we need to print a grid. I'm not going to be using any fancy game libraries, and I'll be writing in C++ because it's faster and better than Python. After all, Python may be able to do everything, but it does so badly. We'll just repeatedly print a 6x10 grid onto the terminal, wait for a bit, and then clear and repeat, so it looks like the grid is constant, but the pieces move around within it. Now we just need to make things move around. We'll do this first by moving a single letter. In code, characters like A, B, and C, and so on, are represented by numbers, so we can basically just take the number representation of the letter A and add a random number between 0 and 25 inclusive to get a random letter. Then we can start the piece in the top corner, and at each iteration, we can increment its y coordinate so it appears to move down. When the piece reaches the bottom or another letter, we want to save it in that place, so we store it in a vector, basically a storage system of moves, to show all the pieces each time we print the grid. We need to be able to move the piece left or right. To do this, we use multithreading, which is basically where we enable simultaneous actions to happen. We leave a function running continuously on the side, which waits for an A or D input, and upon receiving this piece's x coordinate is updated. So now we have a letter falling down, moving left or right on command, and being saved when it can't move anymore. How then do we plan on checking if valid words are made? Each time the piece reaches a point where it can't move anymore, we'll take the row that the piece has reached and use it to get the other pieces on that row. If there are 4 of them, it means we've put 4 characters into that row and so filled it up completely. We sort these pieces by x coordinate to get the word in the correct order from left to right. Now I found the Scrabble dictionary in text file format somewhere online. So basically, at the start of the program we read the file and each line gets put into an unsorted set, which is basically a very efficient method of storing and retrieving things because we have to scan literally hundreds of thousands of words pretty often. In fact, since we're dealing with only 4-letter words, we only need to store these 4-letter words. Each time we get a word in the grid, we check if it exists, and if it does, we make it disappear by going back to the moves vector and removing these moves from it. Now the word disappears, but I want to move everything above that word down 1 position. We do this by going through all stored pieces above a certain y threshold and incrementing their y coordinates. So this is great. Now what we need to do is track score. There are probably better ways of doing this, but I just made a map which stores key value pairs. So basically each value, such as score, is associated with a certain key, i.e. the letter A. So when you look up what the map contains for the A key, it returns the A score, and so on. In this case, A is worth 1 point. Then we just need to sum the scores of the individual letters and voila, it works. I realised pretty quickly that the random number generator that we use is pretty terrible at being random, and also the supposed uniform distribution of possible letters means that there's the use of many horrible letters like Q and J and X and so on. Instead, I found online the frequencies that letters show up in the English language by percentage, and made a 100 character array which contains the alphabet in these proportions. So, for example, there are 9 A's because A basically comes up about 9% of the time. This was so much better and made it a lot easier to actually play. There are still a ton of bugs, but for a quick draft, it isn't bad.